Hello everyone, and this is a redo of one of my older tutorials, which is modeling a spiral staircase. This is part of, I have like a Houdini intro series that was recorded in like Houdini 16. So since then, a lot of stuff has changed. A lot of it has remained the same, but quite a bit has changed as well. So I decided I should, start re-recording some of the old stuff. So I'm starting off with this one. Okay, so before we get to modeling this, a small announcement. The Black Friday sale is currently going on my website. So if you're interested in any of my commercial Houdini trainings, it's 30% off on everything till 1st of December. This includes my latest training, which is like Flippy Murder Season 2. So yeah, the link is given below in the description and the code is Friday. Okay, so let's get started. So if you've seen that older tutorial, the big difference that comes up is instead of using copy stamping, we are now using for each. Okay, so that's the big change. Okay, so how to do that or how to use that and sort of, incorporate all those old techniques in here is what primarily we're going to take a look at. If you haven't seen that, it's fine. This is just everything new that is there in Houdini. Okay, so I'm going to start off with the step and this pillar on the side. Okay, and then we'll start building the staircase from there. Okay, so what I'll do is I'm going to take a simple line. This will be the length of my step and I'm going to keep it in the X direction. And I don't need any segments or points in this, like 2 points is good enough. And then I need another line. And this will be, so we can call this as step length. Okay, and then this will be the step width. And if you want, you can color them. So just press C and you can, give it a color. Okay, and this we'll keep it in the Z direction. But what I want is I want it in the middle. Okay, because it's always starting, from 0. So there is a node called match size. So take match size and we'll plug it in after the step width and it'll just automatically push it to 0. Okay, like it has a bunch of options here. By default, everything goes to 0. So you don't need to do anything. And I'll make this like 0.4. Okay, and then take a sweep node and we can just, this will come into the backbone, like the step length, and this comes in here. Now it won't show up because the direction is going to be weird because sweep kind of does that. So what you need to do is come here and come to yaw and rotate it 90 in the yaw axis, in the yaw, and there you go. So this is fine. Okay, so that's the length of the step. So we can sort of like, control it how much we want, and this is the width. Okay, now I want to give it some thickness. So take a poly extrude and I can just give it some thickness. This is not exactly like an intro lesson, but yeah, I'm expecting you have like some basic knowledge of Houdini. Okay. Okay, and then make sure you turn on output back because by default it doesn't make the back face. So you have to sort of turn that on. And then lastly, I just want to give it some beveling. So I'll just take a poly bevel. So you can just type in bevel and switch it to edges and give it like a little bit. Okay, that's too much. Yeah, you can keep it like this, which will be like, harder, or we can give it some divisions and make it rounded, so you can go with this as well. Now, the next thing is I want like a pillar over here, like for a, at the edge of the step. So what I'm going to do is I want to copy something at the, at the edge of this, but I want to be able to control like where it gets copied. So the simplest thing to do is take a carve node and I'm going to take this line and plug it in there. And I'm going to take the carve, turn off first U, turn on second U. Okay, so we can sort of define, and I want to copy it to this point. So take a group by range, and in the group by range, I can just plug this in and we'll call it end and change this to points. Take end to 1 and invert the range. So the advantage of this is that if I, just for example, like if I put in as many points in here, it will always select, see, no matter how many points come into this place, it will always select the last point. Of course, we only have 2 points, but that's the advantage of it. And then I can take a line, and this will be let's just call it rod. I don't know. And I can do a copy to points. Let me just push this out a little bit. Yeah. And this will be end. Yeah. And plug that in here and this over there. And there you go. So the advantage now is that this becomes the distance, like if you look at the step here, see, this is where we want it to be. Okay, so you can do stuff like that. Okay. So you can call this something. You can call this as rod distance. So wherever, I think whatever has parameters that we can control, we'll just color them yellow. Now, the last thing I want to do with this is I want it like not going through the step. It should be on top. So what you can do is take a transform here after the line and take this poly extrude value and right click and copy parameter and put that in the Y translate. So paste relative reference. So now what happens is that if we merge these two together, okay, and the advantage now is that if I move this, see, that the height of it is how much that line moves, so it will always be on top of the step. So we don't want to merge this right now. We'll we want to do a few more things with this. So firstly, we'll take a sweep here and I'll give it a sweep and just change this to like round tube and a little thinner. Yeah. Okay. And we also, let's say I want like a sphere on top. So I can just take a sphere and I'll keep this to polygon. Or we can also just keep it to primitive if you want, but fine, polygon is fine. And what I want to do is with this line, again, I want to do the same thing we did here, which is I want to select the top point. Okay. So do one thing, like it will generate a group, like this group will carry forward in here. Like you can see, like it has a group here called end. So get rid of that one. So take a delete and you'll find something called group delete. Okay. So get rid of whatever group is in here. And then I can copy paste this group range here again. So you'll get, it'll select the top one. So now you're back to having like 1 point in end. And I can copy this, take a copy to points and plug that in there. And this will be end. Yeah. And just make it like tiny. So just see how thick you want it to be. And with the sweep again, you want to do like end caps. So just give it like single polygon. So I can merge these two together. Let's also give them some color. Okay, so I'll take a color and I'll make the rod like golden or something. And then I'll make this thing red. Just so that, like we get some color differentiation between them. And then I can merge these together. So there you go, like you have your basic step. And yeah, so now like the width won't do much, like this is fine. This is the length, see, and that's your rod height. Okay, and this is the rod distance. Okay. So we have like everything that we want. Okay, now let's do one thing. Let's set up the spiral staircase. And then I can just copy this in there. Okay, so what I'll do is I'm just going to take a box temporarily. The reason I'm doing it this way is just so you kind of understand another thing about Houdini, which is you can sort of do something with like a very basic proxy object and then replace it with your entire procedural system at a later time, and everything will still pretty much work. So what I want to do is I just want to take this and do the same thing, do a match size. Except I want this above ground. So just come into Y and do min. And then in X also do min. There you go. Okay. And then I'll just kind of adjust it. So just roughly make it the same size. So this will be my step. Now what I want is I want to take a transform and it should be like how far away do we want to keep it? Because there's going to be like a pillar in the middle. So let's just call this distance from center. And we'll just give it a color as well. Okay, now let's take care of our actual spiral. Now there are a couple of ways to do this now. Okay, but what I'm going to do is I'm going to try and recreate what I used to do with the older method, which was like using copy stamping and doing that. So the old copy stamp node is still there, but you know that is supposed to be outdated now. So what I'm going to do instead is we're going to do it through for each. So I have a bunch of tutorials already on how to use for each. So this is now sort of like, you know, how you apply that to like an actual thing. So what I'm going to do is I'm going to take a line, and this line will be my number of copies. Okay, so I'm just going to call it number of copies. Okay, and I just give it like a whole bunch of points and no height. So I have 50 points here. Okay, or let's just keep it like 25. 25 points all in the same place, and I can use the point number to do what I want to do. So the next thing I want to do is I'm going to take something called as a wrangle node. So the wrangle node will allow me to type in some vec stuff. So we don't need too much. What I need to do is I just need to control the rotation, and I need to control the height or the movement. Okay, so let's plug this in and we'll call it controls, and just give this some color as well. Let's make this red. What we want is on a per point number. Like the difference with the copy transform or the copy stamping was that you put in a value, but that value is sort of incremental, right? So if I type in 30, that means every copy gets like, if the first copy is 30, the next one becomes 60, and then the one after that becomes like 90. So it sort of keeps, you know, like multiplying, like it keeps getting like a 30, 30, 30, like, you know, going on. It's not like all of them are going to be 30. It's incrementally sort of adding on to it. So what we need is we need to sort of replicate that same thing here. So which means that we need the rotation value multiplied by each individual point number. So what I'll do is I'll do a float. I'll generate a float value. I'll call it f at ROT is equal to, let's say each step is going to be 30 degrees multiplied by the point number. So at PT now. So point number is PT now. Okay. And for the height, I want to do the same thing, which is I want to do f at, let's call it move, is equal to let's say 0.2 into into at PT now. So this is fine. Now we're going to take a for each. So we do for each point, and then we take a copy to points. Okay, so plug this in over here. The points come in there, this comes over there, and we plug in the box. So right now nothing is going to happen. It's just like all the boxes over here. Okay, so now what we do is we take a transform here. Just watch my for each videos, you know, all of this has previously been explained in that. But what we want to do is we want to call these values that have been generated here, which you can see, like if I take this and I do a split left right and I look at the geometry spreadsheet, then you will see the values that have been, see, so this is 30, 60, 90, 120. These are my rotation values. We want to apply these values to my transform over here. So the way to do that is using a point function. Okay, so come in here and we need to call in this rotation value into our y rotation over here. So the code is basically one line. And welcome to Houdini. You have to write shit like this all the time. Okay, so take a point function. So it's called a point. Okay, and what it needs is which is the node you want to call the value from, what is the point number, what is the attribute called, and what is the index in the attribute. So the index basically means that if it's a vector, okay, so if it's 3 values, like color is 3 values, right? So do you want RGB? So if it's R, then it's 0. If it's G, then it's 1. And then if it's B, it's 2. You know, so it doesn't do 1, 2, 3. It does 0, 1, 2. So it starts from 0. Okay, but in our case, it's a float value, so it will always be 0. So what we want is, let's keep it we want to bring in, we can't bring it in from here because there's nothing happening here. Like everything is happening in the for each. So we want to bring it in from the for each. So I'm just going to make this short and call it for each A. Come in here and then you do point, and whatever you need to call will be in double inverted commas. You do like dot dot slash and type in for each, it will find it automatically. Okay, so you have for each A, close that. Then the next thing it needs is, which is the point number. Now when you're inside a for each, you only have 1 point because it's a lot of cycling through the points. So inside the for each only 1 point exists, so which is 0. Then it needs the name of the attribute, which is ROT, and then what's the index? The index is 0. Okay, so you do 0 and there you go. Okay, so now we have 25 of them, but there's no height, so they're all like, you know, doing that. Okay, now we want to do the same thing for the move, okay, for the height. So just take this and we can do like Control C, go to the Y translate, and the difference, the only thing will change is the name over here. So we just come in here and this will be MOVE, and there you go, done. Okay, now let's make a few changes in here. First of all, like if you've seen the older tutorial, okay, there used to be a technique that was being used called, we were doing like a 360-degree divided by total number of points. So what that would do is, like if you have 2 points or 2 copies, then it will automatically be like 0 and 180 degrees. Okay, so if you're doing like 360 divided by total number of copies, that's the value it will give. So if you have like 4, then it will just do 90 automatically. Okay, so if you want to recreate that over here, okay, what you want to do is you want to take like 360 divided by, you want to divide it by the total number of points. Okay, so total number of points is called numpt. And this whole thing, so this will give me like 1 value. And then that value, so this value is equal, so we're doing 360 divided by 25. We have 25 points, okay. And then that needs to incrementally multiply to every point number. So we multiply it with @ttnum, okay. And you close this, and the advantage of this is that now, no matter how many points we have, if I look at it from top, it will always just form a circle. See, so as I keep lowering this, it will always distribute inside a circle. See, there you go, 4 points, 5 points, whatever, you know, it will always be in a circle. But let's say I want a little more control on this. So instead of doing a 360, I can make a channel of my own. Okay, so I can just do CH, which will make a channel for me. And let's call it ROT and close that. And I want to do the same thing here as well. Okay, so let's do CH and let's call it height. Okay. And click here, it will generate both the values. I just want to make one change, which is it by default goes between 0 and 1, okay, which is very irritating. So just come in here, come to edit parameter interface, and you will find ROT and increase this to let's say 960. Okay, so that will give me like enough values for degrees. Okay, and just to apply. So this, see, so now we can do this and we can adjust the height. And there you go. So spiral staircase. Okay, so this is cool. We're done with this. Now all we need to do is take this guy, bring it down here. I don't need this. Just replace it with that and done. We have our spiral staircase. Okay, so this is the advantage of having a procedural system, is that, you know, we can test it on a simple object and then replace it. Now let's take care of the final stuff, which is, firstly, I need like a handle. Like this is just the sticks, right? So we need like a rod going between them. And then I also need something in the middle. Okay, so what we're going to do is we're going to do that after the copy is done. So here I need to add something, which is I want to add like a single point into this. So at this place, I'm going to take an add node. So an add node does a lot of things, but it also generates like 1 point. So if I just come in here and I can just say 1 point. So see, it's generated like 1 point over there. Like we can look at that. There you go. And I'm going to put this into a group. I'll call it rail. This will be points and we will merge it with this. Okay, so now what happens is that if I come back here, and you will, I don't know if you will be able to see it, but somewhere in there is 1 point, okay, which is there. You go like rail. It's 20 points because we have 20 steps. Like if you look at this, you have 20 steps. Let's also get rid of, like it's generated another group. So we'll come into delete and we're just going to get rid of end. Okay, so what I can do is I can just take a blast, or you can take a split. Like we can do a bunch of things here. Just take a split, and I want to split the rail and points. So if we come here, okay, it's picked up the color, but there you go, see. And then just take an add. Okay, so this is the other thing the add node can do, which is I can just take this, come to polygon and click on by group, and that's it. It'll just connect all of them into a single line. So this is actually not a bad way to just generate a spiral as well. And then just take a sweep node and we can give it some thickness. So just do like round tube, and I'll make it grid. I don't think like pink is a good color because it's like not really working over here, but okay, we'll change that. So plug this in and there you go. Maybe I can change the color. And let's make it slightly dark or something. We'll make it red, but yeah. Okay, we need it to be thinner. There you go. Okay, so now the final thing is I need to make the central column. Now that has to come in before we move it. Okay, so take an add node, another one. We'll again create 1 point and create a group for this. We'll call this center. So points, and we'll call this center. And this will also merge here. But it will merge in after, because otherwise that will also rotate, or that will also move away from 0. We don't want it to move away from 0. So that will merge in after the distance. Okay, so it will come in here. So if I look at this, you'll see that there is, 1 point in the middle. Okay, like a line. And I can just take this and like if I take a null here, so you'll see like we have that. So I can take another split at this point. And this will be, hold on, let's take this. We'll do delete unused groups. And this will be center points. We'll just do invert selection. So this is fine, but see, there's nothing in the middle. And then I can just take all of this, do Control C, Control V, plug this in over here. So you'll get like, a rod in the middle. Now we just need to define like the size of this. So the size of this should be equal to like how much we are moving away from the center. So what I can do very easily is come into this distance from center. I can right click, copy this value, come into sweep, and take the radius and do paste relative reference. There you go. Okay, and we can keep this to flat, or you can just take this and make it like really tiny. Actually, hold on, no, just make it single polygon. And that's it. So if I just take this and merge it in, and we get that. See, so the advantage now is that if I come in here to my transform and I move it in the X, where was it? Yeah, there you go. See, so as I move this step away, you'll see that, this automatically, the size automatically changes. Okay. And yeah, that's pretty much it. So now you can so this length doesn't mean anything. Okay, like don't do anything with that. So you can just take this and we can like, control the height from here. We can control like, how much it should spin. If you want it to be like slightly more, we can just add a value in there. I can take this sweep and do like plus 0.01, or let's try 0.1. Yeah, so it sort of intersects with that, so it looks a little better. And then of course with the step we can do, whatever we want. So if we can sort of adjust this, make it smaller, any of those things can be done. Okay. All right, so this is pretty much it. Now there is another way to do this. Like we could probably do like make an actual spiral and then do like orientation along curve and everything, but I think that will probably be more complicated than this. Okay, this gives you everything. Like this gives the central column and the spiral and everything at the same time. So life becomes a little bit more, not easy, but you have like a more controllable thing. Anyway, so what I'll do is I'll go through some of my older stuff and I'll look at how many things have changed where, and try to sort of update them to the latest version. Okay, that's pretty much it.